Hi everyone and welcome to my lesson. Today we are going to talk about how to use product rule and quotient rule to find the derivative of the function. Now let's introduce the learning outcomes. Apply the product rule on derivatives. Apply the quotient rule on derivative. Solve real-life problems using the product rule and quotient rule. We have a new keywords, product rule and quotient rule. Let's start with the two examples. We need to find the derivative of y by using the normal rules of differentiation. To find y prime, we need to distribute these branches before applying the normal rules of differentiation to each of resultant terms. Y equal x to power 2 multiply x to power 2 equal x to power 4. X to power 2 multiplied by negative x equal negative x to power 3. Positive 2x multiplied by x to power 2 equal positive 2x to power 3. 2x multiplied by negative x equal negative 2x to power 2. Last, negative 1 by x to power 2 equal negative x to power 2. Positive 1 multiply x equal x. Then we can simplify x to power 4. We have here negative x to power 3. Positive 2x to power 3 equal positive x to power 3. We have negative 2x to power 2 minus 2x to power 2 equal negative 3x to power 2 plus x. Then we can find the derivative of y. Y prime equal 4x to power 3. Here we applied the normal rule called the power rule. D by dx of a x to power n equal a n x to power n minus 1. Then we can apply again this rule to find the derivative of x to power 3 equal 3x to power 2 minus 6x plus 1. This is our derivative. But here in second derivative, find y prime if y equal 2x to power 4 minus 3x to power 3 plus 5x plus 2. Product by x to power 2 minus square root of x plus 2 over x. It is not easy to distribute these branches before applying the normal rule of differentiation. Then we need another rule to make it simple. The new rule called product rule. Let us to start with product rule. The product rule states that the derivative of f of x times g of x equal the derivative of f of x times g of x plus f of x times the derivative of g of x. We will begin by considering a simple example of the application of this rule. Example 1. Find the derivative of y if y equal x to power 2 minus x plus 1 times x to power 2 plus 2x. Here we have an equation which is a product of two functions. Since this is the case, we can find the derivative of this function by applying the product rule. First function is f of x equal x to power 2 minus x plus 1. Then we can find the derivative of f of x. F prime x equal 2x minus 1. Here we applied the normal rule in differentiation d by dx of a x to power n equal a n x to power n minus 1. Then the second function is g of x equal x to power 2 plus 2x. Then we can find the derivative of j prime equal 2x plus 2. Product rule says d by dx of f of x times g of x equal f prime x times g of x plus f of x times g prime of x. Let's substitute what we know into the formula of the product rule. Y prime equal f prime x 2x minus 1. G of x equal x to the power 2 plus 2x plus f of x equal x to the power 2 minus x plus 1 times g prime equal 2x plus 2. Then distribute this parentheses. 2x multiply by x to the power 2 equal to x to the power 3 plus 2x times 2x equal 4x to the power 2 minus 1 times x to the power 2 equal minus x to the power 2 minus 2x plus 2x to the power 3 plus 2x to the power 2 minus 2x to the power 2 minus 2x plus 2x plus 2. Simplify. 2x power 3 plus 2x to the power 3 equal 4x to the power 3, 4x to the power 2, negative x to the power 2, positive 2x to the power 2, negative x to the power 2. You can cancel it. Then we have 4 minus 1 equal 3x to the power 2. Negative 2x, positive 2x, cancel negative. We have negative 2x. Then the last one plus 2. This is the derivative of the function y. Same question. But I tell you, how do you know? By easy way to remember the product rule. The product rule states that the derivative of f times j equal f prime times j plus f times j prime. How I can remember this rule by easy way? Let me to tell you how to can remember this rule by easy way. Write the first function at the left and the second function at the right. Then find each derivative of each function on the top, f prime, j function j prime. Then you can use cross multiplication. F prime times j, f prime times j plus f times j prime. This is our rule. You can use here, the first function is x to the power 2 minus 3x plus 2. The second function, x to the power 2 plus 2x. Find the derivative for each function. 2x minus 3, 2x plus 2. Then we can find y prime equal, apply cross multiplication, 2x minus 3 times x to the power 2 plus 2x plus x to the power 3 minus 3x plus 2 times 2x plus 2. Then you can simplify this parentheses and find y prime. Example 2. Find an equation of the tangent line to y equal x to the power 3 minus 3x plus 2 times x to the power 3 minus 2x plus 3 at the point 0 and 6. In order to find the equation of the line, we need a point. We have a point here. And a slope. We don't have a slope. But we can find the slope by taking the derivative of the function y. Then we need to find the derivative of y. We can see here first function is x to the power 3 minus 3x plus 2. Second function x to the power 3 minus 2x plus 3. Find the derivative of each function, 3x to the power 2 minus 3. The derivative of second function equal 3x to the power 2 minus 2. Then we can apply product rule to find y prime. The derivative of the first function, 3x to the power 2 minus 3, times the second one, x to the power 3 minus 2x plus 3, plus first function, x to the power 3 minus 3x plus 2, times the derivative of second one, 3x to the power 2 minus 2. Here we don't need to simplify this derivative. We need to find the slope at y prime at x equal, from our point x equal 0. Then only make substitution. Then we can find negative 3 by positive 3 equal negative 9. Positive 2 times negative 2 equal negative 4. Then we have the slope equal negative 13. Then we can use the equation of the line in this form. Y equal the slope m times x minus x naught plus y naught. X naught, y naught, the coordinates of the point. And the slope is m equal negative 13. Substitute negative 13 times x minus x naught here equals 0 plus y naught equals 6. Simplify, we can find y equal negative 13x plus 6. This is an equation of the tangent line to the curve y. Another example about product rule, example 3. Revenue equals price times quantity. Suppose that the current price is 2.40 dirhams and 12,000 items are sold as the price. If the price is increasing at the rate of 10 fills per year and the quantity sold decreased at the rate of 1,500 items per year, at what rate the revenue change? Here we don't any function for price or quantity, but we have a relation between revenue and price and quantity. The revenue as a function of t equal price as a function of t times quantity as a function of t. The revenue R of t equal price B of t times Q of t, where R of t is a revenue, Q of t is quantity sold, and B of t is the price, all at time t. We don't have formulas for any of these functions, but from the product rule we have R prime of t equal B prime of t Q of t plus B of t times Q prime of t. And we have information about each of these terms from our example. The initial price B of 0 equal 2.40 dirham. And the rate of exchange of the price is B prime 0 equal 10 fills per year. Here we must convert fills to dirham. 10 over 100 equal 0.1 dirham per year. The initial quantity Q of 0 equal 12,000 items. And the rate of change of the quantity is Q prime 0 equal, pay attention here, the quantity sold decreased, then the rate of change in quantity must be negative. Negative 1,500 items per year. We can substitute in the rate of change in revenue, and we get R prime 0 equal P prime at T equal 0 equal 0.1 times the quantity is 12,000 plus the current price equal 2.40 dirham times Q prime equal negative 1,500 items per year. Use your calculator to find this value. You will find it equal to negative 2,400 dirham per year. This means the revenue is decreased at rate of 2,400 dirham per year. In this part of our lesson, we have learned that we can apply the product rule to find the derivative of the product of two functions. We have learned that for two functions f and g, f x and g of x, if we need to find the derivative of the product of f of x times g of x equal the derivative of f of x times g of x plus f of x times g prime of x. You can remember this rule by easy way. Only write f of x on the left, g of x on the right. Then you can find each derivative, f prime x, j prime x. Then you can use cross multiplication to remember this rule. In this part of our lesson, we will learn how to find the derivative of a function using quotient rule. We will be looking at various examples of how it can be used. Quotient rule. Suppose that f and g are differentiable, then d by dx f of x over g of x equal f prime x times g of x minus f of x times g prime of x over g of x to power 2. Provided g of x doesn't equal 0. Notice that the numerator in the quotient rule looks very much like the product rule, but with a minus sign between the two terms. For this reason, you need to be very careful with the order. Example 1. Compute the derivative of h of x equal x to power 2 minus 2 over x to power 3 plus 1. Here we can use quotient rule. Let f of x, the first function, equal x to power 2 minus 2. Then f prime of x equal 2x. And g of x equal x to power 3 plus 1. Then g prime of x equal 3x to power 2. You can use our rule, quotient rule, which says d by dx of f of x over g of x equal f prime of x times g of x minus f of x times g prime of x over g of x to power 2. Then we can substitute to find h prime. h prime x equal f prime x equal to x times g of x equal x to the power 3 plus 1 minus f of x equal x to the power 2 minus 2 times g prime of x equal 3x to the power 2 over g of x equal x to the power 3 plus 1 all to the power 2. Then we can simplify 2x times x to the power 3 equal 2x to the power 4 plus 2x minus 3x to the power 4 plus 6x to the power 2 over x to the power 3 plus 1 over to the power 2 equal 2x to the power 4 minus 3x to the power 4 equal negative x to the power 4 plus 6x to the power 2 plus 2x over x to the power 3 plus 1 to the power 2. This is the derivative of h of x. Another example, find an equation of the tangent line to the curve y equal e to the power x over 1 plus x to the power 2 at the point 1 and e over 2. To find the equation of the tangent line, we must have the slope and the point. We have here a point, but we don't have a slope. But we can find the slope by taking a derivative of y. Then we need to find y prime. Y prime equal, here we can apply quotient rule because we have two functions. The first function is e to the power x, and second function is 1 plus x to the power 2. You can find the derivative of e to the power x equal e to the power x, and the derivative of the second function is 2x. Then we can find the derivative of y. First, second derivative to the power 2, 1 plus x to the power 2 to the power 2. Then we can use cross multiplication, e to the power x times 1 plus x to the power 2 minus e to the power x times 2x. Then we can simplify this derivative. Then we have y prime equal e to the power x 1 plus x to the power 2 minus 2x over 1 plus x to the power 2 to the power 2. Then we can find the slope at x equal 1, y prime at x equal 1 equal e to the power 1, 1 plus 1 to the power 2 minus 2 over 1 plus 1 to the power 2. This equal 0. Then we can use the equation of tangent y equal m x minus x prime plus y prime, which x prime and y prime is a coordinate of the point, and m equal the slope. Then we can substitute 0 x minus 1 plus e over 2. Then we have the equation of the tangent equal e over 2. This means the tangent line is a horizontal line at y equal e over 2. Example 3, a golf ball of mass 0.05 kilogram struck by a golf club of mass m kilogram with speed 50 meters per second. will have an initial speed of u of m equal 83 m over m plus 0.05 meter per second. Show that u prime of m is greater than 0 and interpret this in golf term. Compute u prime 0.15 and u prime 0.20. We have our function here. We can use the quotient rule because we have a rational function. To find u prime. U prime m equal, first square the denominator, m plus 0.05 to power 2. Find the derivative of the numerator, 83, times the denominator, the second function, m plus 0.05, minus the first function, 83, m, times the derivative of second function is 1. Then you can simplify. Expand the brackets. 83m plus 83 times 0.05 equal 4.15 minus 83m over m plus 0.05 to power 2. Then we can cancel 83 with 83. Then we have u prime of m equal 4.15 over m plus 0.05 all to power 2. Both the numerator and denominator are positive, so u prime of m is greater than 0. This means u of m increases as m increases. We can see that with another way. A positive slope of all tangent line indicated that the graph of u of m should rise from left to right as the graph shown. In golf terms, this says that all other things being equal, the greater the mass of the club, the greater the velocity of the ball will be. Second part of our question, compute u prime of 0.15 and u prime of 0.20. Only you can substitute a u prime to find the value of it. U prime of m equal 4.15 over m plus 0.05 to power 2. We need to find the value of u prime 0.15 equal 4.15 over 0.15 plus 0.05 to power 2. Use your calculator to find this value. Then we will find it equal 103.75. By same way, we can find u prime 0.20 equal 4.15 over 0.20 plus 0.05 to power 2. We can find it equal 66.4. Another example. If f of x equals square root of x times g of x and g of 1 equal 2 and g prime 1 equal 2, find f prime 1. First, rewrite f of x equal x to power 1 half times g of x. Then we can apply product rule. Product rule says f prime x equal the derivative of first function 1/2 x to power negative 1/2 times second function g of x plus the first function times the derivative of second function g prime of x. Then we can rewrite x to power negative 1/2 like this, 1 over 2 square root of x, g of x, plus square root of x, g prime x. Then we can find f prime 1 equal 1 over 2 square root of 1, g of 1, plus g of 1, g prime of 1. Then we can use our given g of 1 equal to and g prime 1 equal to. Then we can substitute here 1 over 2 g1 equal to plus 1 times g prime of 1 equal 2. Then we can find the value equal 1 plus 2 equal 3. Then f prime 1 equal 3. Another example, if h of x equal f of x over g of x, find h prime 2 by using given information, and g of x doesn't equal 0. We have a function h of x equal f of x over g of x. Then we can apply quotient rule. Then we can find h prime x equal f prime x times g of x minus f of x times g prime x over g of x to power 2. Here we need to find h prime of 2. Substitute by x equal to, we find f prime 2, g of 2 minus f of 2, g prime of 2 over g of 2 to power 2. Then we can use our given information from this table. f prime 2 equal negative 1, g of 2 equal 4 minus f of 2 equal 3 times g of prime 2 equal negative 3 over g of 2 equal 4 to power 2. Then we can find the value by using calculator. Negative 4 plus 9 over 16 equal 5 over 16. Thank you for all, and goodbye.